Good morning, sir. My name is Redilito Menel Mazo, BSEd Mathematics, and this is my final examination in Calculus 3. So, this is my first problem in limits. So, the first problem is limits as r is approaches to 1, the square root of 8r minus 1 all over r plus 3. As I notice, if I will substitute the r value with 1, so our denominator in our equation equates to 4. So it's not intermediate form. So as I notice in our problem, if I will substitute the value of r to 1, so our value in denominator doesn't equal to 0. So it is not interminate or 0, 0. So we will we will substitute only the 4 or the 1 value in r. So we have the square root of 8 times 1 plus 1 all over 1 plus 3. And then we will simplify. We have the square root of 9 all over the square root of 4. And last, our equation equates to the limit of 3 over 2 as r approaches to 1. We have our second example, or we have the second problem. We have the derivative of tan t all over cos t minus 4. Then we will apply quotient rule, which is the prime y is equal to f prime times g minus f times g prime all over g squared. We will apply this in the equation above. Negative 4 6 squared t plus 6 t plus sin t times tan all over cos t minus 4 squared. Okay, we have the third problem. We have the integral of the square root of t of 1 over t minus t times dt all over divided by t squared. Then we will use the third theorem, which divides the terms into 3. We have the integral square root of t 1 over t minus integral square root t times integral square root of dt over t squared. Then we will simplify using the theorem 5. We will apply integral. We have negative 1/2 t minus 1/2 t times 1 over square root of 1/3 t cube times square root dt plus c. Then we have negative 1/2 t minus 1/2 t will become negative t, and then bring down the equation above, and then we have 1 over the square root of 1/3 t cube times dt square root of dt plus c. We have the last problem. We have a definite integral. We have the integral 1 over negative 2 x plus 1 the square root of x plus 3 dy. Since I observed that there is a 2 problem here, so we will use the chain theorem. We have the chain rule, I mean. So then we will have to let u is equal to x plus 3. Then we have du over dx is equal to 1, since it becomes 1 because we use the derivative. Then we will multiply both sides. We have which is the multiplication of a property of inequality. So the result is du is equal to dx. Then we have the integral of u 1 raised to the power of 1/2 du. Then substitute, then use theorem 5. Then u raised to the power of 1/2 plus 1, it becomes to 3 over 2. Same at the denominator, we have 3 over 2 plus c. Then let's simplify. So we have 2 over 3 u raised to the power of 3 over 2 plus c. Then we will move to, we will try to substitute the u. So u becomes x plus 3. So we have 2 over 3 times 1 plus 3, since we already substitute the 1. Then raise the power of 3 over 2 minus 2 over 3 times negative 2 plus 3 raise the power of 3 over 2. Then simplify. So we have our last answer. We have 1 over 0.13. Thank you, sir.